Can you hear me now? I actually just gave the whole lecture whilst I was muted, so that's us done. No. Okay, so sorry about that. All right, so I actually forgot to upload the slides. I thought I had done them when I did lecture 5, but I have not. So I will upload them halfway through. Um, don't worry, you can see them on the screen, so everything is okay. This is the first lecture I've done online in a really, really long time, so hopefully the internet holds out. I am at uni, so it could drop out at any time. All right, how's everyone feeling? Is everyone feeling good after yesterday? Oh, I forgot, there is a delay, isn't there? Bad, no. We're going to be doing arrays. It's going to be the best. Um, and I thought since yesterday's Kahoot was a bit iffy, I'm going to go over structs again today, and I haven't decided whether or not to do them before arrays or after arrays. So I'm just letting the day and the afternoon take us wherever it may take us. Um, we could do a poll. Do you want to do structs rehash before arrays, or do you want to do arrays first? What's the vibe? And Sophie and Bella, if you can hear me, if one of you could do the poll, thank you so much. And enums, don't worry, I will be going over enums, but I'm going to do enums not at the same time so that it's not completely overwhelming and I overwhelm you with everything. All right, looks like we want to maybe do structs first. Okay, let's quickly do this quickly. I don't do anything quickly because I'll go on 3 tangents. But let's do structs first, and then we will start arrays. And then we can combine arrays and structs. We can do functions with arrays. We can do all sorts of things. I love week 3 because we can do so much more than what we can do in week 1 and 2. Thank you, Captain Obvious. That was a good statement. Okay, so let's talk about structs. Okay, so what's the point of structs? Who can tell me, and I'm sorry if I'm asking something that you already know, but who can tell me why we would want a variable type like a struct? We have ints, we have doubles, we have chars, we have all sorts of things. Why would we want can I make a Survivor struct? No, I cannot because I don't watch enough Survivor, but I am obsessed with the Winter Olympics, so we're going to do maybe like a Winter Olympics struct for a Winter Olympian. Yeah, so basically, if you have an int variable type, that's always going to be an int. If you have a double, it always has to be a double. If you have a char, it always has to be a char. And what we will learn about arrays in a second is that it's also all homogeneous, is that every single thing is going to be the same thing. So what struct allows us to do is a structure allows us to hold together a few things that relate to the one central thing, but they can be of different types. So in my struct, I can have an int, a double, a char, a string, an enum. I can have all sorts of things, but the one thing that holds it in common is that it's all related. So let's say you've got a student, each one of you, you'll have a ZID, you'll have a name, you'll have your surname, you might have your date of birth, you might have what subjects you're taking. So all of these things make up your record, and so it's useful to be able to group it together. And so a struct allows you to group things together like that. So yeah, so kind of what you were saying in the chat as well. So it allows us to have like a record. So let's say, for example, let's do one together. This is a really good, no, I was like, oh, my keyboard's not working. This would have been a really good time for my keyboard to decide to not participate in the event. Okay, I don't want to do that. My VS Code has exited the building. I'm sorry. Okay, here we are. We're back in the building. I did it on the side so that it's easier to see. So what I'll do is I am going to do, well, I had in mind to do Winter Olympics? Is anyone into the Winter Olympics? Has anyone been watching the Winter Olympics? Well, watched. But the Winter Paralympics are coming. They're going to be so cool as well. Ah, Alyssa. Obsessed. And ice hockey. I forgot her name, but her three brothers. They were just a vibe. Okay. I'm just seeing, could I please zoom in? Okay, can you tell me how my code, can you see the code? You cannot see the code. Let me create, how is that? Is that better? Okay, all right. So just let me know if it's getting small again or if it's unfocused or whatever else. Okay, fantastic. Let's do just a struct for a Winter Olympian, and then, you know, maybe we can just do one off the bat for something else. Then we'll go into arrays. Okay, I'm going to do, and let me make it available to you so you can see the code. Okay, and oh, I'm an idiot. Let me get rid of those. So all that Chmod does is it allows us to change the read and write access of the file so that you can see it, or that others can see it, or that others can edit it, depending what you want the access to be. The number 755 is what tells which, is what says what kind of access I want to give that file. Let me clear this. You know, oh, I love computers, but why does nothing ever work the way I just want it to? Okay, let's do it. And now I have to go down the big path again. Must be so fun watching me do this all the time. Okay, here we are. Okay, let's do our struct. Okay, so the first things first, I'm just going to hash include my input output so that I can do some printing later on. And then I'm just going to just create the skeleton of my file. Note the space. I've been shamed. Okay, so I've got everything going on, and what I would like to do now is I would like to demonstrate what structs are and how to declare, initialize, and use structs in C. Okay, so what we have going on is we need to define a struct first. I keep wanting to turn to my other computer because that's where the chat is, but I'm just gonna. Okay, so the first thing is first, for a struct, what we do is we defined it outside the main. So we're going to define the struct outside the main. And what that allows us to do is it allows us to use the struct across, you know, our whole main function, across all the code, across all the different functions as well. So I'm going to create a struct the same way that I have an int, the same way that I do a double. I say that I want a struct. So the first thing I'd say is the type of variable that I want, and I want a struct. And then I will say, and I'm going to athlete. Okay, so that's going to be how my struct is referred to. Now that struct is going to be made up of some things, and I'm going to put those in curly braces. So what should we have for this athlete? Let's have a number. So we'll have their bib number, and that's going to give us an int. I won't be able to have a name because we haven't done strings yet. So how about we do an age? So we'll do int age. Okay, and then we're going to do, what else should we do? I want a double. Someone give me a double. What can I do? What else can I save for this athlete? So I'm creating basically a record of this athlete, and I want their bib number, I want their age, I want their 6'7", obviously. Height, we could do height. We don't really care what their height. Score, I love that. Let's do their double is going to be their score because that's, oh, what country? Let's do an int country code. So right now I've got a whole bunch of things that define this one athlete. So what I'm saying is I want a structure of an athlete, and that structure is going to have in it a bib number, age, a score, and a country code. So those four very different things will make up one record for an athlete. So when I define my struct outside the main, you will note that here I will put a semicolon at the end of my definition, okay? Because I have made a declaration and I will finish it with a semicolon. So don't forget to do that, or of course the compiler will complain. Okay, great. So now that I've defined the struct, what that has given me is I have a certain definition, and now I want to be able to use that struct. So the second thing I'm going to do is I'm going to declare a struct. And to declare a struct, what I'll do is I'll say exactly the same way when we declare an int, we say int x or int y or int number. So I want to declare a struct of type struct athlete because I want to be using it, because that's what I called it over here. And now I need to give it a name, the same way that I give any variable a name. So for example, I'm going to have a skater. Yep. So that means I now have a variable called skater, and that variable is of type struct athlete, which means that skater in it has, okay, I'm going to try doing something to draw it up for you. So what that means, this is going to be really messy, I'm so sorry. So I have this variable skater. Oh, this is a mess. And inside this variable, I'm going to have, did I have to use such descriptive names? I'm going to have their bib number. I'm going to have their age. I'm going to have their score. And finally, I'm going to have the country code. Ugh. I'm just going to write code, but it should be country code. So these four things are all part of Skater, which means that anytime I actually move something into my struct, or I need to know which one I am actually going to be using. I can't just say, so if I have an int, I'll say int x is equal to 3, and we know that that's an int, so that goes into the variable x. Now I can't do the same for Skater because Skater has 4 different things in it. It has code, it has bib number, it has age, and it has score. So anytime that I place something into Skater, or access it, I need to be able to say which one I'm actually using. And for that, I use a little dot. And the dot is what lets me access each member of that struct. So let's give it a whirl. Okay, I'm going to erase that. And let's use scanf to do it. So let's do a printf, and we'll say enter a enter a bib number. And then we're going to use scanf, and we're going to read the bib number. So the bib number is an int, which means that we're using a %d format specifier, and then we're going to place it into our Skater. Okay, so we still use the ampersand because we need to access the address of, and then my variable name is Skater, so I'm placing it into Skater, but now I need to, because Skater is a struct with 4 things in it, I need to be able to say which member I need to access. Now I want to place it into bib number, so I use the dot, and then I say bib number, and what that does is it puts whatever number is scanned in from here into the Skater and into the bib number. Okay, great. So now I've got a bib number. Let's do the same thing for age. And this is when I will regret having so many members of this struct. So enter the age of the skater. And we're going to do the same thing. So age is an int, which means we'll use a %d. We'll use the ampersand to access the memory, and we will go skater. And this time we're going to place it into the age member. So I'm going to use the variable name skater, the dot to say which member I want, and then I'm going to put it inside age. Okay, great. Now we've got an age, so now we want a score. So enter the score for the skater. And the same thing here, we're going to scan in a score. A score is a double, so we're going to scan in not AD and LF, and we're going to place it inside skater, the variable, and we're going to put a dot to access the score member, and we're going to place that in there. Okay, great. So, and last one, the country code. So let's do one last one. So enter the country code. And let's scan that in. We've got another int, so it's going to be another %d. And I'm going to place it also into the skater, but this time I'm going to access the country code member. Okay, that's fantastic. Hypothetically speaking, we have now got a whole bunch of things inside this skater variable. So we filled out every single member of the skater variable. But there's no way to see what on earth is going on. So what we're going to do is we're going to print those things out, okay? And we're going to see whether or not it's working or not. Let's just print out, well, let's just do all of them and then, okay. So we have, which skater are we doing? Okay, let's do printf skater with bib number is years old. Oh, how messy is this? I'm giving you quite an example of what not to do. Okay, so we have two variables here. I want the bib number. Again, I'll have the variable, and to access the bib number, I'll use the dot to go into the member. So, and then I also want the age. So I'm going to use the dot, the variable name, the dot, and then age is, okay, great. And let's do one more printf statement, and now we'll say, I'm just going to new line there because that's going to be ugly even when we print it out. The score is, let's say that, and now we need to access that score, so we're going to go into skater dot and score, which will allow us to access the right member of the variable. And finally, we're going to say and it's going to be skater country code. I'm just going to add new lines so it's easier to read. Okay, great. Let's have a look what that does for us and whether or not it works, and then we can take it from there, I suppose. Well, it's not going to do anything because I haven't saved it. So let's compile it. Excellent, and now let's run it. Okay, bib number. Give me some numbers. 6. Okay, bib number 6, or 7, of course. Age of the skater, 21. What's the score? What score are we giving? Was it a good skate? Was it a bad skate? Did they crash? Did they do an amazing job? What did they do? How did they go? 99.9. Oh. All right, let's give 99.9 for that skate. And the country code, let's do Australia. And then it's printed out, skater with 6 bib number, which is what we put in, is 21 years old, which is what we did. And the score that they have is 99.9 to 2 decimal places, because that is what I asked it to do by doing the 0.2 in front of LF here and representing 61 Australia. Okay, so Structs. Kind of getting it. How do we feel about Structs? Is that like a little rehash? Did that work? Sophie, can you please do a poll? I don't know if you can hear me. And we will be using, I will do arrays and then I will do a struct in the arrays. It's just another type of variable basically. So a struct is a variable, but what it lets us do is it lets us store pieces of information that are different types but are related in some way. It allows us to group something together. Yeah, don't worry. The dots for now, just wait till we get to week 7, then you'll have arrows as well, which will be so fun for you. So fun. Fun? So fun. I'm going to do one thing at a time. So I'll do enums next week. Don't worry, you don't have to know arrows yet. That's going to be in week 7-ish, maybe week 5. Okay. Sophie, I like that you took my need for negative thing seriously. Thank you. All right, let's go back to arrays. So today we're going to do one-dimensional arrays only. Okay, I've just kind of skimmed over all of this. We don't care about functions right now. We're going to do functions in a second. Thank you very much. So different types of problems will require different types of variables and different types of data structures. In 1511, we learned 2 different data structures. That's arrays, which is what we're doing now. And then in the second part of the term, we're going to learn linked lists, which is after flexibility week. So both are quite important. Both are, basic building blocks of like how you understand programming. One allows you to understand memory management a little bit better. One allows you to really kind of understand the very first citing of a data structure. So don't worry, in 1511, we keep it really simple. We also don't really care about efficiency. So like how fast the computer runs, how much memory you're wasting. That all comes later. So for now, we just want you to get a hang of using these data structures and data types, and each problem will have an optimum solution where the structures and the variables that we use changes. Okay, so arrays. They are homogeneous. I did say that before, but it was preemptive. So basically, an array is a collection of variables that are all of the same type. So if I have an array of size 20, all 20 of those elements will be of the same type. So if I declare that I want an array of ints, each one is going to be an int. I can't have ints and doubles in there. I can't have ints and chars. So it all has to be the same, which is quite different to how struct deals with things. But you can have an array of structs, which means that each index of an array holds a struct, which we're going to go into it. Don't worry. First, we're going to do the simplest of simple. We're going to do just an int array to show you what it is and how it works. So we can access any variable in an array easily because it's an indexed data structure, which means that just by knowing the index, we can access anywhere in the array. And we can also change any variable in that collection easily as well, because we can access it by using the index of that array. So what a terrible example. How boring, but it will have to do. So let's say I want to record how much tea I drink for a week. And just to be transparent, I drink a lot of tea. Probably enough caffeine of like 10 coffees is what I get from the tea that I consume. That's going to be, quite intense if I do an int for every single day. Like let's say I'll do int Monday, int Tuesday, int Wednesday, int Thursday, int Friday, int Saturday, int Sunday. Oh my God, I struggled there. So I'm going to have 7 ints to record each day what I'm consuming. What about if for 365 days of the year, I wanted to record a daily temperature? I mean, I cannot have 365 variables that are kind of all the same, that are going to house an int each that I might then, work with. Because even performing any operations on that, you can kind of see how that would have a lot of repetition, but also would get very, very messy. You would not really be able to do it very easily. The number of seasons of Survivor that Henry has watched, I just felt like I needed to put that in there. That would also be an unmanageable amount of variables that we would need to house that. Amount of time daily that I spend walking my dogs. Again, if I do that for the year, it's going to be huge. Can you think of anything else? Any other examples that would get out of hand if I were tracking them over a week or over a year? What do you reckon? He wrote all this. I have no doubt. That was, I think he even slipped Survivor references into his job interview. So, how many times people say 6, 7 in this course? What a great example. If we were to calculate that, that would get kind of busy. Date of classes, grains of sand on the beach. The homework we do every week, even every day. Hours of sleep in a year, those are great. And of course, 6, 7, yes. So all of those would get very tedious if I had a variable for each one of them and then tried to do something with that. So if I decide to group them instead, so let's say I have my tea consumption for a week and I decide to group all of those together, that's what makes an array. So I only have one variable and it's that array. I can access it as a collection and I can loop through and access each individual item of that collection. So one of the most important things of an array, besides the fact that it's homogeneous, is that it's 0 index, which means that we start counting at 0. It does not start at 1, it starts at 0. So this is one of the most common errors, is where you go past the end of the array. Because it starts at 0, if I have 7 elements, it will finish at 6. And so one of the most common mistakes that you make when you first learn programming language, but also when you first learn arrays, is that you go past the end of the array into a void. And then you have some issues, obviously, because there are some memory issues with accessing past the end of the array. So you will get good at finding these off by 1 errors and hopefully not making them as you go. So using that example of the tea consumption, if I had 7 variables, each one was holding the amount of teas I had that day, it would get messy if I wanted to do it for a year. Yeah? So instead what I do is I have an array. And to make an array, first I will say the data type that I want that array to house. So in my case, I'm counting the number of teas I'm having, so it's going to be an int array. So what that means straight away is that every single element of that array is going to be an int. I cannot change from that. I'm going to name my variable, so in this case, tea drinking, and then to make it an array or to make it a collection of things, what I'm going to do is I'm going to have the square brackets and then a number inside the square brackets. And this number is the size of the array. So if I wanted to track it for 1 week, I need 7 days. I need an array of size 7. So that means that I'm going to have 7 things in the array. And that means my array indexes are going to be 0, 1, 2, 3, 4, 5, 6. Okay, fantastic. Now I can declare an array. Now if I've declared it like this, then I can't then initialize it by doing this. I can't initialize it in this way. But what I can do if I want to hard code the numbers is I can declare and initialize all in one, and you can do that. So I can declare the array by saying what type I want, int, the name of the array, the square brackets, and the size of the array that I want. Then to initialize it, I put the curly brackets and I list the numbers that I want in there, separated by commas. Okay, amazing. So let's do something. I always find it a bit more boring to go through the slides, but let's do some code. What example should we do? You know what? Let's do. I'm going to take. How is everyone feeling? What's the energy levels? Give me from 1 to 10 your energy level right now. I'm going to make an array with that. And I'll use the first 10. I can't do 6, 7. It's got to be 6 or 7. 6, oh, someone has done 6 or 7. 5, 4. Okay, that's too many. All right, let's do a demo array. And then I'm going to use a few of them to create my array. So in this course, we're going to keep arrays stable in that we're not going to dynamically allocate memory, which means we're not going to allocate memory to an array if we've run out of space and we need more. We're not going to do that in this course. Maybe if we have time, I can show you how to do it. But for now, we're going to keep our arrays as the size that they are. And we're going to say that they're not a particularly efficient memory structure, because let's say I decide that I want an array and I'm going to give it size 1000. Yeah. So that means that array is now using, and it's an int array. That array is now using 1000 integers in it. And so the space required for 1000 integers. But then say I only use 5 indexes of that array. So that means I only use 5 ints. I've got 1000, and that means I've wasted a lot of memory, right? But in this course, in this present moment, we don't really care about that. Waste away. But it will become important as we go on later. So we're going to keep it simple, and we're not going to have dynamic allocation for memory for arrays. Okay, let's do it. So let's have this. Why am I doing it under here to make it more complex? My goodness. Okay, first things first. We want to have an array. So let's do a hard code first. Then we're going to go through and see how to use scanf to put it into the array. So let's do a hard code first. So let's declare an array of size 10. Okay, let's do 10. Now tell me, if I have this size 10 and I'm not changing the size of the array, what does that imply? What can I do to that size? My VS Code theme is an A11Y theme. So it's the high accessibility theme. Yeah, let's hash define the size, because the size is not changing, okay? So what we can do is we can hash define size and we can make it 10. Okay, so now let's say we're going to make an array of ints. So I'm going to say I want an array of type ints, which means that everything is going to have ints in it. and we're going to have array, and it's going to be size. So what I have said here is I want an int array. The array is called array energy, and it's got 10 elements in it because size is 10. So what that has created looks something like this. 1, I'm going to regret 10 now, 3, 4, 5, 6, 7, 8. Look at that perfect line. Can I just note that? And my arrays will start at indexing at 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9. So once we read this, it creates this kind of array structure. Note that it's completely empty right now, but the array structure has been created and the memory for that array has been kind of noted. So the reason I need to give the size is that it sets aside the memory that I need, and the fact that I've said that it's an int array and the size of it, it's created basically 10 spaces that are all ints, and the spaces in memory are one after another. So they're sequential, right? They're consecutive. They come one after another. And that means that that's why I can use that indexing to access elements of the array, because I know where in memory how much each int takes, and that means I know how far to move forward to access the next point of the array. Okay, excellent. Now, this is just a declaration of the array. So if I declare it like that and I put my semicolon here, then what I'm going to need to do now is I'm going to potentially need to use a scanf to fill it up, or I'm going to use a for loop to fill it up, depending what I want to do. The other way that I can do it, and this is me hard coding it as well, so just so that you can see how I can do it, I can say, oh, I didn't want that to be a comment, int array energy and still size, but what I can do straight away is I can hard code the values. So I will open a curly bracket and then I will fill it up. Okay, so we've got, I'll just go back, so I'll do 6, 7 first, 6, 7, 4, 1, 4. Someone has 0 energy? That makes me so sad. 5, 10, 1. Lots of 0 energies. So what have I got? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, perfect. So this way over here is we have declared and initialized an array of size 10 of ints. Okay, so we can do it like that as well, okay? So let's keep it like this for now, just so we can see it, and then we'll go back and we'll do a scanf and a printf to see what on earth is going on. Okay, great. So let's go through and print out every element of this array, just so that we can see how we do that. Okay, so what I can do, actually, let's go back. So I can access, so actually I'm going to fill, hang on, sorry. I'm going to fill the array. That's going to be terrible. Let me do yellow. So now if I've done that, what I've done is I've filled up this array. So 6, 7, 4, 1, 4, 0, 5, 10, 1, and 0. So in the case where I've now got a declaration and also an initialization, what's happened is it's created this array and it's also filled up the array with the numbers that I put inside the curly brackets. So now if I want to know, okay, what's array energy at index 3? So at index 3, it's going to be equal to 1. What if I want to know at index 6? Okay, at index 6 is 5, and so on and so forward. So to access an element of the array, I simply need to name the array that I want, and then in brackets I will put which index I want. So if I have index 3 here, then what it's saying is that it wants 1 as the number that is stored in there. If I have index 8, then I'm going, oh, that was unfortunate. I'm going to have 1 again as something that is stored there. So for example, if I were just to print out, just so that you can see it in action, so it's going to be a %d printed out because it's an array of ints. So then to access, I'm going to name my array that I'm using, and then in square brackets, I'll say which element I want. Okay, so if I've got a printf statement and I'm asking for an index of 4, what number do you think this code will print out for me? Okay, so people are saying 4, 4, 4, 4, 4, a few ones, a few fours. Few fours, a few ones. Drum roll, please. Drum roll, and voila. Because this index here is index 4. So if I go to index 4, I will go over here in my array and I will access the number 4. Okay, so if I now go to index 7, what number do we think are going to be, what number is going to be printed if I do index 7? Yeah, it is going to be the 8th number in that array. What have I done wrong? I can see what I've done wrong, what I do wrong every time. I forgot to save. So it was a really anticlimactic movement right there. Okay, and it's 10. Woohoo! Well done, party people. All right, excellent. So that's just being able to access the index of the array. Now, what if I want to print out every single element? There you go. You can access it now. What happens if I want to print out every single element? I can't do, I mean, I could really do printf blah, I could do 0. Then I could do the same thing here for the first one. Then I could do the same thing here for the second one. Then I could do the same thing here for the third one, so on and so forth. That's going to be quite messy, isn't it? Well, I mean, it's going to be ugly. It's not going to be good style. And it's going to be 10 lots of the same thing. And what do we do for that repetition? I can see the chat's going off. Indeed, we have a loop to get rid of this repetition, because we're just going to be increasing by 1 the index each time. So we just need to have a loop. Okay, so in arrays, I often like to use a for loop just because it's easier to track. Okay, so let's do int I is equal to 0. I don't know if you've done for loops. Please tell me you have. Yes, you have, right? For loops? Oh, you have not done a for loop. Oh, well, this is awkward. Ah. Okay, you know what? Let me do a while loop and then I'll turn it into a for loop. How's that? Okay. Okay, great. I'll do a while loop and then we'll turn it into a for loop, just because for loops are neater often in arrays. Okay, excellent. Let's do it in a while loop. So the first thing I need to do is I need to be able to count something. I need to be able to count the index, because that's going to be the thing that's going to be increasing each time. So because I need to be able to count the index, I'm going to need something to hold that counter. I'm going to have an int I because that's the index, and I'm going to start that I at 0 because my arrays always start at 0. So I'm going to make my I equal to a 0 to be able to access the very first element of an array. Okay, so then what's going to be my condition whilst I is what and to what? So how long, if I want to access every single element of this array, how far do I want to be going in the loop? How far do I want to be moving? So I want to start at 0 and I want to go until that I is equal to so I want it to keep going until I is going to be less than the size, or until I is less than or equal to 9. Yeah, so I'm going to go until I is less than size, which means I is less than 10, which means that it will not go into the loop for the 10th go, which I don't want it to do because my indexing is finishing at 9 over here. Okay, excellent. So we've got a while loop, and then I'm going to need to update the while loop. So I'm going to increase my I as part of updating the while loop. So a while loop has my control variable, I check the control variable, and I update the control variable. Okay, fantastic. So I want to be able to print out each item of the array. So I'm going to print out a %d, and I'm going to do a new line just so that it's neat. Okay, and then how will I access the index of the array? What will I do now, do you think? So I'm going to have the name of the array, and then what will I have for my index in the square brackets to say that's what I want? Yeah, perfect. I'm going to have my index in there, so my counter that I'm counting with, so my array energy I. So this while loop should print things out for us. So let's see what it looks like. So let's compile it again, and let's run it again, and let's see it printed out. 6, 7, 4, 1, 4, 0, 5, 10, 1, 0, woohoo! It's doing it, okay? So we've got a while loop here, okay? So it's a while loop because there is the keyword while. So now let's turn this while loop into a for loop. So the nice thing about for loop is that I'm just going to declare my int I in here. So the first thing I'm doing is basically this. I'm going to put this together so that... Okay, so the first step of the for loop is going to be, I'm going to declare the counter and I'm going to set it to 0. I can set it to any number I want, right? But I'm setting it to 0 because my array starts indexing at 0, so I want to start counting at 0. So that's the first thing I do. Then I have a semicolon, and then I say, what is my condition? So the first, I'm basically doing all three, the set a control variable, check the control variable, and update it. I'm doing it all inside the for loop. So now I've done my first things. That means that I've declared a control variable and I have set it to equal to 0. The next thing I'm going to do is the same thing. I'm going to check for the condition. So what condition am I using to check whether or not the loop keeps going? And that's the same one as I've got here, I is less than size. And then the next thing I do is I say what will be the update to my control variable, which is I++. So all that the for loop allows me to do is to do it all at once. So this over here does exactly the same thing. So if I do %d, new line, and then here I have my array energy, and I'm going to access at index I. So let's now get rid of this, and this for loop is now exactly the same. It's doing exactly what this while loop was doing. So let's, if you don't believe me, let's check. So I'll compile it again, And I'll run it again. And I've got 6, 7, 4, 1, 4, 0, 5, 10, 1, 0. So amazing. Yep. How is that? How does that feel? How is your first small taste of a raise? Can we have a poll, please, Sophie, before we take a little break? You know, everything's a little weird when you first learn about it. So that's not a bad thing. It's good to feel a little weird. Yeah, you can do all sorts of things, right? For loops, it doesn't always have to be the same. Ah, what a great question someone asked. Why won't the I be redefined the zero every time the for loop repeats? So the way the for loop works, this is an excellent question because also I'll show you what happens, okay? Oof, this is so exciting. I love this stuff. Okay, I'm going to show you how it runs actually quickly and then we'll take a break. Okay, this is what happens when this for loop executes. So when it goes to line 22 here, what happens is the first thing, it declares the variable I, which is an int, and it makes it equal to 0. Okay, great. Then it checks the condition. So it checks, is I less than size? So size over here is equal to 10, and I currently is 0. So if 0 is less than 10, which it is, it goes into the loop and it prints out the first number. So it's going to print out the number 6. And then it's going to increase I by 1. So then I is going to become 1. And then it's going to check the condition again. Is 1 less than size? Yes, it is. So it's going to go back in and it's going to print out the next one. And then it's going to increase I by 1 again. So it's going to go to 2. And then it's going to check the condition again. And it's going to keep going until that condition is no longer true, in which case it will break out of the for loop. And then anytime, yeah, so that kind of the way it works. All right, there is a poll, excellent. Oh, this is such a positive poll. This is so fun. I love that. You can declare it beforehand, but this I right now exists in this for loop and I want to keep it like in that for loop because it's like a much neater way to do it. And I'll show you the difference once we do something else, something harder. I'll show you when that actually impacts what you're doing and kind of the odd behavior. Well, not odd, it's the right behavior, but it looks odd to us. Okay, we're going to have a 5-minute break. It's 3 o'clock now, so we're going to come back at 3:05. I'll stay on the chat and then we will keep going. So we've got quite a bit more to do with the raise and then who knows, the world is our oyster. Maybe we'll have an array of structs. Maybe we'll play around more with the raise. All right, I'm going to try and upload the slides now. Amazing. I hope everyone had a pleasant 5 minutes. I know it would have been devastating without a raise to keep you company. Let's have a look. What's going on? Why is my screen not updated? What have I done? Oh, it's just the delay. We're all good. Okay, what are the energy levels now? How are we feeling? 0 to 10. Oh, I had a Kahoot quiz. Let's do that. That should bring the energy levels up. Yes, Sophie, thank you. Good vibes. 1000. 6.7. Just had to happen. Still a 1 over there. I don't know how to bring you up. I just don't know how to. Minus? No, we don't want to be going into the negative numbers. No, thank you. I don't really want to erase. I'm going to have to erase that array. We're just going to have to do it again. Oh well. No, why is everyone feeling so negative? We want to feel the vibes. And also, why can I hear not the Kahoot? Arrange that English in a way that makes any sort of sense. Oh, look at these lovely names. Oh, gentle otter. Daring. These are actually terrible, but anyway. I wonder if I will be in the way. I mean, I'm always in the way, but I'm going to remove my camera so that I'm not in the way. All right, amazing. Shall we begin? My camera's off, but I'm obviously dancing. All right, let's see how much we remember from yesterday. That's it. That's the statement. Functions help us. We will learn about different libraries in week 5. Whoa. Oh, not too bad. Yeah, functions do all sorts of things. They reduce the amount of code we need to write because we can avoid repetition. So we can just use a function call. They can help group related things together. They can compute result, return it to the caller. They can do all sorts of things. They are magic. Well, they're not magic. They're just they're functional. Such a dad joke. Okay, smooth lizard. Good for you. Trustworthy lion. Next. All right. Let's see who's next. 50-50. In an ambiguously worded question. Yeah, I just said it very ambiguous. I don't want anyone to, I want to give everyone a chance to have a guessing question. Could have been either one. All right, excellent. Smooth Lizard still on the lead. Oh my God, language. We need to import a library to use functions in C. Did you see me import a library? This is seeing if you were asleep yesterday or not. No one saw me import another library. I just used functions. More than half the people were sleeping. A Smooth Lizard, whoever that is, they're just still in the lead. All right. This is just calling the function. You're not declaring it. When I'm calling it, I don't need to specify the types that I'm calling. I just need to say, give it the two things that I'm calling it with. That's okay. We're going to do more functions. Don't worry. Smooth Lizard has been thrown off the pedestal. Almost perfect. This time, because you're declaring the function, you're going to have the types. And one was an int, one was a double. Just here, int was an A, double was a B, and when you called it here, you did AB, which means that the declaration has an int A, double B. Okay, let's see who's... Mystical Fox, staying on top of the podium. Very good. Well done. Impressive. Even got a fire icon next to the Mystical Fox. You're going to hate me for this one. Sorry in advance. Read the code carefully. Think about it. Not bad. I'm impressed. People really, 3 plus 7 is equal to 10, you would think, but no. Did you know why? So in main, we start running, we've got x is 3, y is 7, result is 0. Then we call the function sum with 3 and 7. It goes to sum and it says int result is equal to 3 plus 7, because the 3 and the 7 are there. And then it returns the results, but it doesn't really have anywhere to store the result. So there is no result here, which means that the result is still 0, which means that it's going to be 3 plus 7 is equal to 0. All right, no, Mystical Fox is been knocked off, and now it's Melodious Ferret. Wow, it's like every adjective they could think of. Okay, last question. If you wanted to store the output of the function, you'd have result is equal to, and then call the function. So it'll do whatever is on the right first, and then assign it to a variable on the left. Okay. Oh, we had you got to see what's going on here. So we've got 5 and 6, and then we print something and we call a function something with 5 and 6, which means it goes here. This x is 5, this y is 6. Then over here, I'm going to assign 4 to the x. And when I go here to do z, it's going to be 4 times 6, which is 24. It will get assigned to the z, and then I'll return the z. So when I come back here, the z is going to print out as the output of the question. It's not evil. It's checking for understanding. There we go. Well done. Now let's see who managed to get onto the first place. Oh, Mystical Fox, still in it. Giving Magpie. I don't know any magpie that has given anything. Oh, that was the Melodious Ferret just stole it on the last 2 questions. Amazing. Oh, and runners up. I saw there was the Smooth Lizard. They tried to make a comeback, but it wasn't going to be. Amazing. Thanks, team. All right, Kahoot is over. Is everyone feeling the energy back up? What's the energy levels now after the Kahoot? With the music, with the whole lot? Do winners get chocolates? If I could throw them through the computer, you would. You can have them on Monday, though. 1 million. Zeros. Ah! No zeros. Not allowed. Oh, 7.6. Someone swapped it around. That's amazing. All right. Oh, Sophie was the 1 million. Oh, amazing. Thank you so much. Pi. That's quite a low value for energy. I feel like you should be energized. There's only like 30 minutes to go. You know you're going to be doing a race. You're feeling excited about it. This is where it's all at. Bella hasn't participated once in the energy. She's feeling no energy. All right, let's see what else we can do with our array. So we now have this array. The array's got a whole bunch of things in. We've printed out the array. Amazing, we can do so many things. How about we now scan into the array just to see that that also works nicely. And just to give you an idea that you can also scan into the array. So I'm going to remove the hard code in this beautiful inline comment, in code comment. Don't do that. I'm just keeping it all, there. And now let's do a scanf to scan it in. So again, I could do scanf and then I could scan in a %d, and yeah, I'm going to place it into my array, and I'm still going to use the ampersand always, and I'm going to go to the array, and I want it to go at index 0. And then I would do the same thing for index 1, and I would do the same thing for index 2, and I would do the same thing, blah, 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 blah. And so tedious and so annoying. And what is the best way to get rid of this repetition? Yeah, Bella, I want to see cartwheels in the lecture. For loop, yes. Amazing. So absolutely, once again, we're going to have another loop to do exactly the same thing, where we're going to just basically scroll through the different indexes. So I'm going to use a for loop, and I'm going to have an int I is equal to 0. I'm going to keep going until I hope someone picks up this mistake. Has anyone picked it up? Yes, the wrong way. The crocodile is eating the bigger number, but mine is not. So I should be checking that I is less than size, not more than size, because I is not more than size, which means that for loop will never get activated. And to update the condition, I want to I++. And no, I'm not printing, I'm scanning in. So I'm going to do scanf, and I'm going to scanf at %d, and I'm going to place it into my array at the index I, which means that what happens each time is that I increases and I scan into the new one. And this is going to be really ugly, so I'm just going to printf a statement here, just so that we know when it's happening, and then I'm going to scan it in. All right, so let's see what it does. Let's see how it works. Let's see the magic happen. And let's do dcc demo array.c. Oh, thank you, everyone. Good pickup. Well done. Well done. It's always my favorite thing to do wrong because it's so easy to fix. Okay, enter a number. Oh, I suppose I don't feel like I don't have a choice here. Someone did say 0. I'm going to give 2 10s because all the energy. Okay, is that correct? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Perfect. So I've got an array of size 10, and I've 6, 7, 4, 1, 4, 5, 0, 10, 10, 3. So it is working, it's scanning in. Now what happens if I would have had an equal sign here as well? What would that have done? What do we reckon? Would that have... Yep. Yep. It's going to... I think it's really important that you see what it does. So I'm going to compile it again. And this is the really fun thing about it, is that it compiles fine, right? Even though what this will cause us to do is go beyond the end of the array. It's going to go to the 10th index, and there's no such thing, right? There's only 9. So then if I run it, I should have started from 0. That would have been much better. What's that now? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. This is the 11th one, okay? So this is the one that overflowed. So once it put it in there, it said stack buffer overflow. So that's what's telling us that it's gone beyond the end of the array. And the DCC explanation is access past the end of a local variable. Make sure the size of your array is correct. Make sure your array indices are correct. And it's showing us where it's happening. So it's happening here when this I became 10, okay? DCC is so kind and so chivalrous. That is right. DCC is your savior. GCC sometimes lets you have absolute garbage in there. And that's not good either. So DCC is there to help you learn. It was built in-house. Okay, so if you ever see this error, this runtime error, it means that you've gone past the end of the array. Okay, so you know what to do. It means that somewhere you've accessed past the end of this variable and past the end of the memory that you have allocated to this variable. So there's nothing there, which means you can't put anything in there. Yes, you will have DCC in the final exam, but not DCC help or sidekick, just DCC. And you will have auto tests in the final exam as well. Okay, fantastic. Well, this is looking good. Now, what should we do now? I think we should find the maximum number in our array. What do you guys think? Does that sound good? Let's find the maximum number. And because we're having such a good time, we're having so much fun, we're going to do it as a function. Why not? Why not? So let's do a function here. Okay, and I'm going to create it as a function. All right, so what do you think will be the inputs into the function? Yeah, so the inputs is going to be some ints, but what is it going to be? You're right, it's going to be ints, but it's going to be, I'm trying to find the maximum in my array of ints. Yeah, so I am going to have to give it an array. Now, and this is why I wanted to do it as a function, is that there is a very special thing. So when you remember me yesterday, maybe you remember, I don't know, some of you might have been asleep, but I was saying that you're not actually passing the thing, it's making a copy and then copying that number into it. So this is going to be like, just think of this something you will just need to do for the next few weeks, and it will make more sense in week 5. Okay? So when you pass a function an array, what it's really passing is the address of the very first index. So what it's doing is, I'm going to draw it up again. Just give me a second. And I'm going to change colors from the yellow back to the blue. Was the blue all right contrast? Okay. So, all right. So we've got an array. So when you're passing, too many comments, let me remove some of these. We don't need some of this. Okay. Let me remove it to make it neater and easier. Do you want me to keep the while loop in there so you can see how one's structured onto the other? How do you feel about the while loop comment staying? Or do you want the while loop removed as well? Okay, I'm going to keep the while loop in there just so you can see how one became the other for a little bit more. Okay, so when we pass an array to a function, okay, what happens is it gives the function the address of this. Now, when it gives the address, so it gives the address just of this element. So when it gives this address, you do not know how big the array is. You do not know anything about this array. You just know the very first index, where to start this array. And the array is sequential, right? So it's one after another. So something else that helps us is to also, anytime we pass an array to a function, we also give the size of that array, right? So that you know how far to go. So for now, just take my word for it. I'm sorry, this is like the ampersand. But in week 5, it will start to make more sense when you actually start to look more into memory and what it means. Okay, and what do we think is going to be the output if I'm finding the maximum number in that array? So if I want the maximum of whatever I've put into the array, I want the maximum, then my output will be an int. So it's going to be the maximum number. Excellent. Okay. And let's name it max energy. All right, amazing. So let's write this function. So the function is returning an int, which means that I'm going to start with int because we've returned an int. Then I'm going to have the name of the function, which is max energy. And then in brackets, I'm going to say what I'm giving this function. I'm giving it an int array, and I'm also giving it a size. Yep, so I'm going to send a little size with it as well. Okay, great. So I've got two things that I've given this array. I've got the array and I've got the size, which means that this function now knows how big that array is and where to access all the different indexes of it and how far to go to not go over the edge and to, miss the whole array. Okay, great. So who can tell me what they think we will need to do to run through this array searching for a maximum number? What do we think? So we're going to have a loop somewhere. So the size right now is a different variable altogether. Okay, it's not the hash define. I've just made it a different variable. Okay, so I'm definitely going to have a loop in there, and the loop is going to loop through my array. So I'm going to just set up a little loop, and the loop is going to go until the size that I'm given. And it's because I wanted to demonstrate. So this size that I've passed to this function, that's the size that I want to be going until, okay? Because I've said how big this array is. You'll see what I mean in a second. And then I'm going to update with I++. Okay, great. Now I need to be able, I've got my loop. I might need a variable to keep track of a max number. So I'm going to have a variable int max. Now, right now, I've declared this variable. I've got a variable named max. It's of type int. I've declared it. I haven't initialized it to anything. So what happens inside this for loop when I try and do some sort of comparison if I want to see whether or not it's a maximum number or not? Yeah, that's great. Someone's answered it in the chat. So I've declared it, but I'm also going to initialize it. And this is a really common way to find maximum numbers or minimum numbers when you're doing it in code, is that I will set it to the first thing inside my array. So I'm going to say the maximum number is the very first thing inside that array. Okay, so I'm going to set it to the very first element of that array, and then I'm going to compare each element of the array to the max and see if it's bigger or not. And if it's bigger, then I'm going to reassign the maximum number, but if not, then I won't. And another excellent point, so now that I've got my array 0 as the first maximum number, I can actually start my counting at 1, because if this is the maximum, then I don't need to compare myself to exactly the same number. I will now be comparing it to the next number. So in fact, I'm starting from 1. And don't worry if you're still kind of rocky, I'm going to run through this code as though I'm the computer, and I'm going to run through to show you what it's actually doing so that you can see how it works. Okay, so now I need to have a comparison. So I'm going to use an if statement to compare, and I'm going to say if array at index I is greater than the max, then what I want to do is I want that to be the maximum number now. So I'm going to have the max is now going to be equal to array at index I. And then that's it. And then I'm going to keep going. And then by the end here, I will return the max back. Okay? Because that's where my maximum one is stored. Okay, just quickly, who has lost me? And then I will run through the code. Do you want me to run through the code as though I am the machine? Yeah, it's all good. This is a really normal place to become lost. So let's run through it. Okay, so let's pretend, okay, that I'm going to fill this array, okay, with just random numbers, just because it's easier to not deal with abstract numbers. Let's fill it up with numbers. So let's say we're going to scan in some numbers. I'll do 6, 7, 1, 3, 4, 5. I'm going to have 9. I'm going to have 10. I'm going to have 0. And I'm going to have 2. Okay, excellent. So let's say that this is my array. These are the numbers stored in the array. Okay, I will enter my function. Let's pretend I've called the function. We'll do that in a second, and I'll do that. So what I've given the function is this array. So this array over here and the size of it. So I'll move to line 40, and on line 40 I've declared a new variable, and that variable is called max. So now I've just created a new variable, max, and what I've done is I've assigned it a value, and that value is stored in array 0. So I'll go to array at index 0, and I can see that it is equal to 6, which means that max has a value of 6. I'll now move to the next line of code, and I'll have my for loop. So now I've got a new variable that I've declared. It's an I, and I've started I at 1. So I has a value of 1. I'm going to check whether that 1 is less than size. Size was passed to the array, so let's just pretend that that size passed is 10. So when I check whether 1 is less than 10, it is, which means I'll go into the for loop, and I'm going to now check this. If array at index I, and I is equal to 1, so array at index 1 is equal to 7. So is 7 greater than the max number? And the max number now is 6. So I'm checking, is whatever is stored in array at index 1, so is 7 greater than 6? Yes, it is. So if it is, I'm going to enter into this if statement, and I'm going to reassign. So my max is now going to be equal to whatever was at array at index 1. And at index 1 we had 7. So instead of 6, I'm now assigning it a 7. I'm going to come out of this if statement, and I'm going to increase my I. So my I is now going to become 2, and I'm going to check the condition again. So is 2 less than 10? Yes, it is. So I'm going to enter the for loop again, and I'm going to check the if statement now. Is array at index I, and my I is now equal to 2, so I am now over here. So is my array at index 2, so is 1 greater than max, and max is 7. So is 1 greater than 7? No, it's not. So I'm going to skip over this if statement, and then I'm going to increase I by 1. And then I'm going to check the condition again. So is 3 less than 10? Yes, it is. I'm going to go into the for loop, and I'm going to check again. Is array at index 3? So I'm now over here. So is the value 3 greater than max, which is 7? No, it's not. So I skip the if statement. I don't go into it. I increase I by 1. So it now becomes 4. And I'll check my condition again. Is 4 less than 10? Yes, it is, which means I go into the for loop and I do the if statement. Is array at I, which means I'm now over here. So is the array at index 4, which is equal to 4, is 4 greater than the max, which is 7? So is 4 greater than 7? No, it's not. So I skip over this if statement and I increase my I by 1, and then I check the condition again. So is 5 less than 10? Yes, it is. So I go into this for loop, and now I'm on the if statement and I'm at index 5. So now I'm on this element of the array. So is whatever's stored at index 5, so the number 5, greater than the max, which is 7? So is 5 greater than 7? No, it's not. So I skip over this, and then I go back out. I increase my I by 1. It becomes 6. And I check again, is 6 less than 10? Yes, it is. So I'll go into the for loop and I'll check again. So now I've moved over here. Okay, and I'm checking is whatever's at array at index 6, so is the number 9 greater than the max, which is 7? Yes, it is. So it is, which means I'll go into the if statement and I'll now assign the value of array I. So I'll access array I, which is the value 9, and then I'll assign it to the max. So that means my max is now going to be 9. So I'll come out, I'll increase my I by 1 again, so it will become 7, which means that I've also moved to this element here, and I'll check is 7 less than 10? Yes, it is. So I'll check now, is whatever's stored at that index of the array at the index 7, so is 10 greater than 9? Yes, it is. So I'm going to go into the if statement, I'm going to access whatever's at array I, which is the number 10, and I'm going to assign it to the max. So now the max is going to become 10. And then I'll come out of this if statement and I'll go back, I'll increase my I by 1, and I'll check the condition again. So I'll check whether 8 is less than 10. It is. I'm going to enter the for loop, and now I'm sitting on the 8th index, so I'm over here. So I'm going to access whatever's in it, and it's 0. Is 0 greater than 10? No, it's not. So I'm going to skip the if statement. I'm going to increase the I by 1, and I'm going to check the condition. Is 9 less than 10? Yes, it is. So I'll enter the for statement. I'll access my whatever's sitting inside this array at index 9, which is 2, and I'm going to check is 2 greater than max, which is 10 right now. No, it's not. So I'll skip this if statement. I'll increase the I, and then I will check my condition. Is 10 less than 10? No, it's not. So I'm going to break out of the for loop, and I'm going to move to here where I will return whatever is sitting inside max, which is the number 10. And voila, that was exhausting because there's 10 elements. How does that feel though now? Does that feel better? Do you understand kind of how it worked? Okay, great. And things will become more clear as you use arrays more and as you kind of learn about these different ways to go about things. Also, I find the best way to, if sometimes a piece of code doesn't make much sense, or if like you're struggling to understand what it's doing, pretend you're the computer and follow it step by step. And then just follow each line of code. And sometimes it really helps to find the mistake, or to find like a little break in your logic, or something that you've written down that may not be quite right. Well, I would, yeah. Oh. All right. Don't worry, I will keep, like, I'll do shorter arrays next time as an example, and I'll keep running things in the code. Yeah, good idea. So let's show, I'm going to remove the annotation because it's making the screen very messy. Okay, so I haven't actually called this function anywhere. I've just written the function, but I haven't called it from my main function. So what I need to do now is I need to call it. So let's call it over here, and we can call it inside a printf. How does that sound? So then we don't need 2 lines. And we can say the maximum of the array is, and then we can %d that, so we can check that things are working. Now we're going to call our function, yeah? So we're going to call our function, and the function is called max energy, and we're giving the function 2 things. I'm giving it the array, and the array is called array energy, and I'm giving it, what else? I'm giving it the size, yep? So I'm going to give it the size, which is 10. So I'm giving it a number, and then I'm also giving it the array. Okay, let's have a look. Semicolon, an overly long line, just for fun. Okay, let's do demo array.c. And what have I forgotten? What do I always forget to do? What have I forgotten? Let's see how well you remember the functions lecture yesterday. Yes, well done. I forgot a prototype. So you can also read what it says, and that's really what it says, that, you know, you've forgotten a prototype yet again. So what I've forgotten to do is I've forgotten to tell C that there is a function coming that's called max energy, and it is doing something. I'm not just making stuff up. I'm not trying to be mean to you. So let's compile it again. Amazing. And now let's run it. And now let's pile it in with some numbers. Okay, so we've got our array. It's got all the different values in it, and it's telling us that the maximum number is 10, which is so nice. Now, if I had this kind of thing in the, I don't know, in a test or whatever, and what do you think, how would I test that my code is working? Would I change, like if I wanted to write that maximum energy function to find the maximum number in the array, what do you think I would change? Where I would enter the 10, what I would do? Auto test. Do not become over reliant on auto tests. I mean, they are very useful, but you should also know how to test your own code. What would I try? Yeah, make it the last number. That's always where mistakes happen. I can make it the last number, the maximum number. And it's working. Excellent. I could also try, I could do that. Oh. So always try to think of ways that it will break. And usually breaks happen, yep, first number, have it be the first thing to see whether or not it's moving. So 10, 9, that's not what I meant to do. Now I've got a 45, that's not meant to be there. Okay, yep, you'd have it as the first. You'd use negative numbers, and you'd always have it as the first and the last thing, because that's usually where drop-offs happen, where the slight logic in code might not account for the last number or the first number. You would use chars, that would definitely break it, absolutely. So all good things. And also, you know, you have this code from the lectures, like take this code, copy it over and break it, right? See what the different errors are, see what, you know, different ways of doing things does, see what, you know, shifting things around does, because C also does things in order. So see what happens if you change the order of things and how that affects the logic, because it allows you to then later find errors much easier in your code as well. All right, we've got 5 minutes. We've got time to write one more function, I reckon. What function should we write? We didn't have time to do a struct of arrays. We'll do it next. Array of structs, rather. I could do a struct of arrays too. Average, you're tired. I can't really write that function. Well, it would be the minimum number of the arrays. Okay, let's add all the numbers. That's a nice one. Oh, sum of energy. Okay, and okay, so let's do a function to sum up the energy levels. I've given away what the output is. What will be the input? Yeah, so the output is int and the input will be, I will need my array and I will do something else. I can do it an average next time because an average I need to talk about something else. Can I explain where the variables are going and which is which? Can you expand on that question, please? Yeah. So I'll give it my array and I need to give it a size. I think what you're saying, because I've called them different things. So they're not necessarily, so this just gets the address of the first thing. I could call it exactly the same thing, but I always, and sometimes people do, but I always like to show that they're not the same variable. It's like a copy of that variable. And again, more when we touch memory will make a bit more sense. But expand on that question and I will answer it. Okay, so we've got the size and the int. So output is int, name is sum of energy, and we're going to give it, again, an int array, and also we're going to give it a size. And I'm going to return something here, and it's going to be some sort of int. Okay, so I'm not going to be doing, array 0 plus array 1 plus array 2 plus array 3 plus array 4 plus array 5 plus array 6, blah, 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 blah. That's going to get a little bit tedious. So I want to, again, have a loop. So the loop is going to become your best friend now, right? Now that you're doing arrays, the way to cycle through arrays, the way to access all the different indexes, the way to manipulate arrays, the way to do things with arrays as a collection is to constantly loop through them and to access every element. So if we want to loop through them to have so we'll have a for loop. I'll do my int I is equal to 0. I is less than size. So again, I is less than size because I'm using the number that's given here. Yeah. Okay, and then I'm going to update the variable with an I++ after the loop has completed. And what I'm going to do is I'm going to write it out completely, not in shorthand. So I'm going to need some sort of variable to hold the sum first. So I'm going to have an int sum to hold the variable. And now, and you can tell me if this is going to work, I'm going to have sum is equal to sum plus array at index I. Will this work or will this break? Yeah, it will break because sum is not initialized here. So when you go in here and you try and access sum at this point over here, right? It's going to say actually sum has no initialized value. There's nothing there, and it will break the whole thing, right? So I need to initialize it to 0. Now, someone's asked, how does a computer know the size is 10 when it's a different variable than size? The way it knows it is when I do, so I've done this print. So if I call this function that I've just written, so if I call the function in here, what was the function called? Sum of energy. When I call it, I give it my array that I have, the array energy, and the other thing I give it is whatever's copied in there. So I'm giving it this size. So when I make this call over here to this function, I pass it this array energy, and I pass it size, which is replaced by 10, which means that this function starts with 10 copied into this int size here, and that array energy copied into this array here, but not the whole thing, right? It's copied, it's just got the first address of it. It knows where to start that array. Okay, should we see it run? I'm not going to forget the prototype this time. I thought it was so perfect. Where did I forget it? There we go. All right. Hey Sophie, whilst I'm running this, can you do a poll of how do we feel about arrays? And don't worry, we're still going with arrays, right? It's not, don't worry, this is just the beginning. I did something where I could not do the sum very quickly, but you just trust that it's working. The sum is 71. And let's do a poll. How are we feeling? How is everyone feeling about arrays? I think this is a lot. This lecture's a lot. From now on, every lecture, mind you, will be a lot. So let's, please also provide like feedback if you've lost it, where you've lost it, what you would like to know. And I will answer the question the next lecture if I don't get to it in the current lecture. Oh, brilliant. That's, okay, so where were we? Why not sum plus array 0? Okay, that's a good question. Because that will, if I have this hard-coded as 0, what that will do is that will only give me the very first element of that array, nothing else. Whereas the I will keep moving and cycling through the I's. So the hash define is it's a preprocessor thing. So it doesn't happen at compile time. It happens in the preprocessor situation. All of the rest of it is at compile time is assigned. You mean int sum is equal to array 0. You could hypothetically do that if you then change something, but for when you're summing things, it's easier to start with a sum of nothing and to then just add each element to it, because then you know that you're not going to make a mistake. All right, so what I'm going to do is I'm going to give you the code. You can provide me some feedback, leave me any questions that you would like answered for next week as well. And then we will talk more next week. What does int array mean again when you're declaring the function? I need to look at my code. Hang on. Do you mean over here, this int array? So this is the input into the function. So what I'm saying is I'm going to give this function an array of integers. And I'm also going to give it the size of that array, because when we pass an array to a function, we're only passing the address of the first element. It is a little bit messy, right? But that's how it works. Yeah. We will talk more about it, don't worry. I'm trying to give it in dribs and drabs so that it doesn't overwhelm. All right, well, thank you all so much for tuning in today. I appreciate it. I hope it was useful, and have a good rest of the week. I hope you have a great week ahead and lots of good COMP1511 stuff. And I look forward to seeing you on Monday with chocolate and the ability to eat chocolate in the lecture. Bye, y'all. Oh God, I just said y'all. That's things that I just need to go and lie down on the floor. Bye, everyone.